What's up, Math Mob? We are back at it again. Today, our topic is solving equations, and our focus question is, what is a general method for solving equations, linear equations? So for our warm-up, I'm going to show you a series of expressions, and I would like you to tell me what the value of x is. So I'm going to give you 30 seconds on each one. You can mentally, we're doing this mentally, so think of what the value of x is and write that down. Okay, so here is our first equation, sorry. Okay, here is number 2. Number 3. And number 4. Okay, so answers to number 1, x is equal to -3. Number 2, x is equal to 1. Number 3, x is equal to -3. And number 4, x is equal to 2. Okay, number 1 says -6x minus 7 is equal to 4x minus 2. Okay, so when I look at a problem like this, I'm looking at specifically the negative numbers. I don't like working with negative numbers if I don't have to. So this -6x, I am going to remove that by adding 6x. And what I do to one side of the equal sign, I have to do to the other side, right? I have to keep it balanced. Just like the hangers. So now I have -7 is equal to 10x minus 2. So my next goal here, as I'm looking at this equation, I want to get this variable by itself. So in order to do that, I'm going to get rid of this minus 2. So if I'm subtracting 2 to get back to 0, I'm going to add 2. I have to do it to both sides. So negative 7 plus 2 is negative 5. So negative 5 is equal to 10. So I could just divide this by 10 and divide this side by 10. So 10 divided by 10 is 1, so I just have 1x is equal to, I could simplify that to negative 1/2. Or if I put in my calculator, negative 5 divided by 10 would be negative 0.5. Okay, let's look at number 2. Number 2 says 1/2 times the quantity 7x minus 6 is equal to 6x minus 10. Okay, so one of the ideas we talked about in our last lesson was using the distributive property to remove parentheses. So if I take 1/2 times 7x, I'm going to end up with a decimal, 3.5. I don't know if I want to do that. So if I double this, so this is 1/2 of this quantity. If I double it, multiply it times 2, then I'm going to end up with 7x minus 6, right? If I take this whole thing here, multiply it by 2, instead of half, I'm going to have one whole, I'm going to have all of this part. So if I multiply this side by 2, I have to multiply this side by 2 also. So I doubled this quantity also, or this expression also. So now I have something a little bit easier to work with. I don't even have decimals to deal with, so I'm pretty happy about that. So let's work on getting the x by itself. So as I'm looking at this, I'm looking at all these terms here to see which one might be the easiest to do, and I'm thinking if I add 20 here, I can get rid of all the subtraction. So 7x is equal to, 7x plus 14, right? Negative 6 plus 20 is positive 14, is equal to 12x. All right. So now I can subtract 7x. I have 14 is equal to 5x. Ooh, that is not a nice number. But if I divide by 5, 14 fifths, or 2 4/5. Or if I write that as a decimal, 2.8. Okay, so go ahead and try numbers 3 and 4 on your own, and we'll do the same thing. We'll go through each of these, and you can compare how you solved it to how I solved it. So go ahead and pause the video, do 3 and 4, and then when you're ready for the solutions, go ahead and hit continue. Okay, number 3. Number 3 says 1/2 times x plus 7 is equal to x plus 13. Okay, so I have a fraction here. I'm not too happy about that. I don't know what I can do about that right now, so that's fine. I think what I'll do on this one is I'm just going to subtract 7 from both sides. Now I have 1/2 x is equal to x plus 6. All right, now, so remember, if there's no number in front of the x, it really means there's a 1 there. So I could do two things. I might have to deal with a negative on this one, because if I subtract 1/2 x from this side, I'll have 1/2 x on this side, but I'll have a 0 over here, and that's okay, but then I'll have to add another step. So I think I'm just going to go ahead and work with the negative number at this point. So I'm going to subtract 1x here and subtract 1x on this side. So I'm going to have 6 is equal to negative 1/2 x. So now negative 1/2 times some number is equal to 6. I think I might be able to do that in my head, but if I couldn't, I could divide each side by negative 1/2. Right. And remember, when you divide by fractions, you're multiplying by the reciprocal. So I'm just going to go ahead and go right to that idea of multiplying by the reciprocal. I'm going to multiply this side by negative 2 and multiply this side by negative 2. So x is equal to 6 times negative 2, negative 12. Okay, number 4. Number 4 says 2 times the quantity x plus 7 is equal to negative 4x plus 14. So looking at this one, I think the easiest way, at least for me, might be to remove the parentheses. So I'm going to use the distributive property to remove these parentheses. So really what this means is I have two groups of x plus 7. So I have two x's and 14. So 2x plus 14 is equal to negative 4x plus 14. Okay, so now what I'm going to do is I'm going to add 4x to both sides. So I have 6x plus 14 is equal to 14. Now I want to get this x by itself, right? So I'm going to subtract 14 and subtract 14. So 6x is equal to 0. Well, there's only one number I can multiply by 6 to get 0, and that's 0. And so the answer has to be 0. All right, so let's take some notes on some of the processes we used here. So what are some things we did to solve all of these equations? One of the things we did was use the distributive property to remove parentheses. And that may or may not be your first step. You might want to wait on that step, but eventually we will have to remove the parentheses somehow to solve for the variable. So for example, in this equation here, when we were solving this equation, the first step, we use the distributive property to remove the parentheses. Okay, the second thing that we did was combine like terms. So if you remember the problem Claire was working on from the last lesson, she had 14x minus 2x, and she was able to combine that to 12x. And then the other things we did were, and it doesn't have to be in any particular order, but we used our properties of equality, right? We added to each side of the equal sign, or subtracted, or multiplied, or divided, in order to make that equation smaller and smaller and smaller, so that we end up with just x is equal to some value. So we used properties of equality. To solve for the variable. So what were some of the things we needed to look out for? So if you remember May's problem, she subtracted values that were inside the parentheses without first removing the parentheses. So she actually had, if you remember, she had 3 times the quantity of 5x plus 9. And she just subtracted the 5x. And she thought that that was okay. Right? She subtracted the 5x from this side, and she subtracted 5x from the other side. But this is more than 5x. This is 3 times 5x. So if she wanted to remove all the x's from this side, she would have had to subtract 15 x's. So remember, if this in the parentheses is a group of some amount. So in this case, it was 3 times whatever's in here. So that is something to watch out for when you're solving equations. Make sure that's why I like removing the parentheses with the distributive property before I start subtracting variables. The other thing to look out for are negative numbers. Negative numbers can be tricky sometimes, so you have to remember your rules for subtracting negative numbers. For example, if we have negative 3 times 2x minus 4. If we're using the distributive property here, remember your multiplication rules. So this would be negative 6x, and negative 3 times negative 4 would be positive 12. But you might be thinking, well, wait a minute, that's just subtracting a positive number. Why is that negative 4? That's a positive 4, we're just subtracting it. Okay, that's true. That's true. We're subtracting 4, so we could write it like this: 3 times 2x minus 4. Negative 3 times 2x is negative 6x. Minus, this is positive 4 now, right? Negative 3 times positive 4 is negative 12. So we're still ending up in this situation where we're subtracting a negative, so we're actually adding, right? We still end up with negative 6x plus 12. So be careful of negative numbers and how they are being multiplied or added or subtracted. Okay, so negative numbers, be careful of them. Be careful of groups or parentheses.